Addressing the first question regarding wall sconces, the decision of whether to replace existing fixtures or blank up the boxes depends on personal preference and the condition of the existing fixtures. If the existing fixtures are in good condition and appealing, they can remain. However, if they are outdated or damaged, replacing them with wall sconces may be a better option. Moving on to the second question concerning the 100 amp fused disconnect switch. Using its line side lugs as a splice point for the house air conditioning unit is a violation of the National Electrical Code, specifically NEC Article 380.12. B, which states that disconnect mean shall not be used as a junction box or as a raceway for conductors feeding through or tapping off. Furthermore, NEC Article 404.9 specifies that disconnect switches should be readily accessible and not located in the same enclosure as the panel board. The conduit should likely pass inspection once an equipment grounding conductor or EG is installed. However, the disconnect switch being utilized as a splice box is not compliant with the NEC. A recommended solution involves installing a separate junction box for the splice and connecting it to the disconnect switch using a short length of conduit. In addition, the gauge change from number 6 to number 8 conductors within the conduit is not recommended. NEC Article 310.15 B1 dictates that conductors entering a raceway, box, or other enclosure should be protected from abrasion and other physical damage, and where conductors pass through walls, ceilings, or floors, they must be protected by approved bushings. Using a 3/4-inch electrical metallic tubing, or IMT, with number 8 conductors may not provide sufficient protection and may not pass inspection. Consider increasing the size of the conduit to 1-inch EMT or utilizing a larger gauge conductor. To summarize the code violations, firstly, the disconnect switch is being used as a junction box or raceway. Secondly, the conductor size changes within the conduit. Thirdly, there's a lack of an equipment grounding conductor. To rectify these issues, firstly, install a separate junction box for splicing. Secondly, maintain consistent conductor size throughout the run. Thirdly, install an equipment grounding conductor within the conduit. Regarding conductor sizing for air conditioning units, several factors must be considered, including the minimum circuit ampacity, the maximum overcurrent protection, and the conductor's ampacity rating. These requirements are generally found in the equipment nameplate and must be adhered to for safe and code-compliant installation. When dealing with disconnect switches, it is crucial to ensure they are readily accessible, as mandated by the NEC. This accessibility ensures that the switch can be easily reached in case of an emergency or for maintenance purposes. The location should be free from obstructions and allow for safe operation of the switch. The NEC provides specific guidelines on the working clearances required around electrical equipment, including disconnect switches. These clearances ensure that there is sufficient space for personnel to safely operate and maintain the equipment. These clearances vary depending on the voltage and configuration of the equipment. Always refer to the NEC for the specific clearance requirements applicable to the installation. Regarding equipment grounding conductors, or EGs, their primary function is to provide a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protection devices such as circuit breakers or fuses. The size of the EGC must be appropriate for the size of the circuit conductors, as specified in NEC Table 250.122. The EGC must be installed in the same raceway or cable as the circuit conductors to ensure effective fault current return. When transitioning between different wiring methods, such as from conduit to non-metallic cable, it is essential to maintain the integrity of the grounding system. This may involve bonding the metal conduit to the equipment grounding conductor in the non-metallic cable. Ensure that all connections are made using approved methods and connectors. Junction boxes must be installed in accordance with the NEC requirements, including those related to accessibility, conductor fill, and box sizing. Junction boxes must be readily accessible without removing any part of the building structure or finish. The number of conductors permitted in a junction box is limited by its size, as specified in NEC Article 314. Splices and terminations within a junction box must be made using approved methods and connectors. When dealing with existing electrical installations, it is important to thoroughly inspect the wiring and equipment for any signs of damage, deterioration, or code violations. This inspection should include checking for proper grounding, conductor sizing, and overcurrent protection. Any deficiencies should be corrected to ensure a safe and code-compliant installation. Working with electricity can be dangerous, and it is essential to take appropriate safety precautions to prevent electrical shock or other injuries. These precautions include de-energizing circuits before working on them, using insulated tools, and wearing appropriate personal protective equipment such as gloves and safety glasses. If you are not qualified to perform electrical work, it is best to hire a licensed electrician. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. It is essential for electricians and other electrical professionals to stay up to date on the latest NEC requirements to ensure that their work is code compliant. Local jurisdictions may have additional electrical codes or regulations that must be followed. It is important to check with the local authorities to determine the specific requirements applicable to the installation. Electrical permits may be required for certain types of electrical work. It is important to obtain the necessary permits before starting any work to ensure that the installation is inspected and approved by the local authorities. Electrical inspections are conducted by qualified inspectors to verify that the installation complies with the NEC and other applicable codes and regulations. It is important to cooperate with the inspector and address any deficiencies that are identified. Proper grounding is essential for electrical safety. It provides a lower impedance path for fault current to return to the source, reducing the risk of electrical shock. The grounding system must be properly installed and maintained to ensure its effectiveness. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices must be properly sized and installed to ensure that they will trip and de-energize the circuit in the event of a fault. Conductors must be properly sized for the load they will carry. The ampacity of a conductor is the maximum amount of current it can safely carry without overheating. The NEC provides tables that specify the ampacity of different types of conductors based on their size, insulation, and installation conditions. Wiring methods such as conduit, cable, and raceway must be properly installed to protect conductors from physical damage and environmental conditions. The NEC specifies the requirements for different types of wiring methods, including their support, spacing, and grounding. Electrical equipment such as panels, disconnects, and lighting fixtures must be properly installed and maintained to ensure their safe and reliable operation. The NEC specifies the requirements for the installation of different types of electrical equipment, including their location, mounting, and grounding. Regular maintenance of electrical systems is essential to prevent failures and ensure their safe operation. This maintenance should include inspecting wiring, equipment, and overcurrent protection devices. Any deficiencies should be corrected promptly. When working on electrical systems, it is important to follow lockout-tagout procedures to prevent accidental energization of circuits. These procedures involve disconnecting the power supply, locking the disconnect switch in the open position, and tagging the switch to indicate that the circuit is being worked on. Electrical safety training is essential for anyone who works on or around electrical systems. This training should cover topics such as electrical hazards, safety procedures, and the proper use of personal protective equipment. It is important to stay informed about changes in the NEC and other electrical codes and regulations. This can be done by attending training courses, reading industry publications, and consulting with electrical experts. Electrical problems can be costly and dangerous. By following the recommendations in this guide, you can help to prevent electrical problems and ensure the safety of your home or business. The grounding electrode system provides a connection to the earth, which helps to stabilize the voltage on the electrical system and provide a path for fault current to return to the source. The grounding electrode system typically consists of a ground rod, ground plate, or metal water pipe that is connected to the grounding conductor in the electrical panel. Bonding is the process of connecting metal parts of the electrical system together to create a low impedance path for fault current. This helps to reduce the risk of electrical shock. Bonding is typically accomplished by using bonding jumpers to connect metal conduit, metal enclosures, and other metal parts of the electrical system. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning, utility switching, or other events. SPD divert the surge current to ground, preventing it from damaging sensitive electronic equipment. Arc fault circuit interrupters, or size, are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. A size trip the circuit breaker when an arc fault is detected, preventing a fire from starting. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. GFCIs trip the circuit breaker when a ground fault is detected, which is a condition where current is leaking from the electrical system to ground. Tamper-resistant receptacles are designed to prevent children from inserting objects into the receptacle slots. These receptacles have a built-in shutter mechanism that prevents access to the slots unless a two-prong plug is inserted. Smoke detectors are designed to detect smoke and provide an early warning of a fire. Smoke detectors should be installed in every bedroom and on every level of the home. Carbon monoxide detectors are designed to detect carbon monoxide, which is a colorless, odorless gas that can be deadly. Carbon monoxide detectors should be installed near sleeping areas and on every level of the home. Electrical fires can be caused by a variety of factors, including overloaded circuits, faulty wiring, and damaged appliances. If you suspect an electrical fire, evacuate the building immediately and call the fire department. Electrical shock can occur when a person comes into contact with a live electrical circuit. Electrical shock can cause a variety of injuries, including burns, muscle spasms, and cardiac arrest. If someone is experiencing electrical shock, do not touch them. Call for emergency assistance immediately. The location of electrical panel should comply with NEC guidelines, ensuring accessibility and safety. Clearances around electrical panels must be maintained for safe operation and maintenance. The NEC provides specific requirements for these clearances based on voltage and equipment configuration. Electrical panels should not be located in hazardous locations, such as areas prone to dampness or the presence of flammable materials. Proper labeling of circuits within the electrical panel is essential for easy identification and maintenance. Circuit directory should be accurate and up-to-date. Overcrowding of conductors within the electrical panel can lead to overheating and potential hazards. The NEC provides guidelines for conductor fill in electrical panels. Damaged or deteriorated wiring within the electrical panel should be replaced promptly to prevent electrical hazards. Regular inspections of electrical panels can help identify potential problems and ensure safe operation. Qualified electricians should conduct these inspections. Modifications to electrical panels should be performed by qualified electricians and comply with NEC requirements. Proper grounding and bonding of electrical panels are essential for electrical safety. The grounding system should be inspected regularly to ensure its effectiveness. Surge protection devices can be installed in electrical panels to protect against voltage surges and transients. These devices help protect sensitive electronic equipment from damage. Arc fault circuit interrupters and ground fault circuit interrupters provide additional protection against electrical fires and shock hazards. These devices should be installed in accordance with NEC requirements. Unused openings in electrical panels should be closed off to prevent access to live electrical parts. Proper maintenance of electrical panels can extend their lifespan and ensure reliable operation. This maintenance should include cleaning, tightening connections, and inspecting for damage. When working on electrical panels, it is important to follow lockout-tagout procedures to prevent accidental energization of circuits. Qualified electricians should perform all electrical work on electrical panels. Improper wiring or modifications can create serious electrical hazards. The NEC provides comprehensive guidelines for the safe installation and maintenance of electrical panels. Adherence to these guidelines is essential for electrical safety. Local jurisdictions may have additional electrical codes or regulations that must be followed. It is important to check with the local authorities to determine the specific requirements applicable to the installation. Electrical permits may be required for certain types of electrical work. It is important to obtain the necessary permits before starting any work to ensure that the installation is inspected and approved by the local authorities. Electrical inspections are conducted by qualified inspectors to verify that the installation complies with the NEC and other applicable codes and regulations. It is important to cooperate with the inspector and address any deficiencies that are identified. By following these guidelines, you can help ensure the safe and reliable operation of electrical panels. Regular inspections and maintenance can prevent electrical problems and protect your home or business from electrical hazards. Remember to always consult with a qualified electrician for any electrical work or repairs. Their expertise can help ensure that the work is done safely and in accordance with the NEC and other applicable codes and regulations. Stay informed about electrical safety and best practices to protect yourself and others from electrical hazards. Electrical safety is a shared responsibility, and we all play a role in preventing electrical accidents and injuries. The use of proper wire connectors is crucial for making safe and reliable electrical connections. Wire connectors are designed to securely join two or more wires together, providing a low-resistance connection that will not loosen or corrode over time. There are many different types of wire connectors available, each designed for specific applications. Some common types of wire connectors include wire nuts, crimp connectors, and push-in connectors. Wire nuts are a popular type of wire connector that is used to join two or more wires together by twisting them together and then screwing a plastic cap over the connection. Crimp connectors are another common type of wire connector that is used to join two or more wires together by crimping a metal sleeve over the connection. Push-in connectors are a newer type of wire connector that allows wires to be connected simply by pushing them into the connector. When selecting wire connectors, it is important to choose connectors that are appropriate for the size and type of wires being connected. The wire connector should also be rated for the voltage and amperage of the circuit. It is important to follow the manufacturer's instructions when installing wire connectors. This will help ensure that the connection is made properly and that it is safe and reliable. Improperly installed wire connectors can lead to loose connections, which can cause overheating, electrical fires, and other hazards. Always use the correct tool for the job when installing wire connectors. Using the wrong tool can damage the connector or the wires, which can lead to a faulty connection. Inspect wire connectors regularly to ensure that they are in good condition. Replace any connectors that are damaged or corroded. When working on electrical circuits, it is important to energize the circuit before making any connections. This will help prevent electrical shock. Always use insulated tools when working on electrical circuits. This will help protect you from electrical shock. Wear appropriate personal protective equipment when working on electrical circuits. This may include safety glasses, gloves, and other protective gear. If you are not qualified to perform electrical work, it is best to hire a licensed electrician. A licensed electrician has the training and experience to safely and properly install wire connectors and other electrical components. Remember, electrical safety is always the top priority. By following these tips, you can help ensure that your electrical connections are safe and reliable.